Hello everyone, hopefully you're doing well. In this video, we're going to complete section 2.3, Graphs That Enlighten. If for some reasons you missed the beginning of this section, we already covered a few of these graphs, we went on how to construct or display data using a dot plots, and we construct also stem and leaf plot or stem plots, and we went over one examples or two examples of it. If for some reasons you miss it, I strongly advise you to go back and watch it. And we also complete a few one exercises on time series graph, and another wonderful graph that we can use to display quantitative data. All these three graphs that we use in the previous video is to display quantitative data. Now, what we're going to do is to continue, using some other graphs, to display data, but this time we would focus on qualitative data. So another way to graph qualitative data is, one way to graph qualitative data is to use a Pareto chart. So we said that a Pareto chart is a vertical bar graph in which the height of each bar represents frequency or relative frequency, right? So you see a graph of bars of equal width to show frequencies of categorical, we said qualitative data. The bars may or may not be separated by small gaps. So there are gaps between each bar. So the difference between a Pareto the difference between a Pareto bar chart and a bar chart, a Pareto chart and a bar chart in itself. The difference between Pareto or bar chart and also uh, a histogram is the fact that the histogram, all the bars are attached to one another, but for Pareto and bar chart, there may be some gap between each bars, right? So for us with the Pareto, also what you need to remember about the Pareto graphs, it shows the relative distribution of categorical data so that it's easier to compare the difference. Other characteristic of Pareto, a Pareto chart is a bar chart for categorical data with the added stipulation that the bars are arranged in descending order. So the highest bar come first and so far. So you go from the highest to the shortest according to frequency. So the bars decrease in height from left to right. For Pareto charts also, it shows the relative distribution of categorical data so that it's easier to compare the different categories. So it also draws attention to the more important categories. Like this is an examples of Pareto chart. Take a look on it. I'm gonna let you check it. All right. So for this Pareto chart, as you can see, this Pareto chart, it's arranged from left to right, with the highest bars come first. So that's very important to say that. Remember, it's represent qualitative data or categorical data. So you cannot say like you're gonna put one first, second, third, fourth, but it's categorical. As you can see, this example shows a pie chart for causes of fatal plane crash, pilot error, mechanical sabotage, weather, or other. So pilot error is the largest causes of fatal plane crashes, right? So that's Pareto chart displayed. Another techniques we're gonna use to display qualitative data, because we said pie charts is another one, right? So that's a very common graph that depicts categorical data as slice of a circle, right? In which the size of each slice is proportional to the frequency count. So as we said, pie chart provides a very convenient way to display qualitative data graphically as a percent of a whole. So remember, we said that the pie chart, all right. So pie chart in itself is a circle. Like if you construct a circle like this, okay. So we can say that it's a circle that is divided into sectors that represent categories, right? The area of each sector is proportional to the frequency of each category. So in most cases, you will be interpreting a pie chart or constructing one using technology. So we're gonna do in a different video. Remember, our goal is to show you how to construct all these graphs from this section in Excel. So remember, the total in real life or in algebra or pre-calculus, you learn that a circle is 360 degrees, or in radians, what it would be? Yeah, it would be 2 pi. Now remember, 360 degrees, in order to convert every relative frequency into degrees, you need to take the percent you have, right? The percent you have, and you multiply it with 360. So that's how you're gonna find the portion of each sector in this circle. So we call it pie chart. So what pie chart does, because as we said, we need to study the whole thing. So pie charts really is very helpful in this case. You know, it shows the distribution of categorical data in a commonly used format. All right, so that's why the pie chart. And you can enjoy constructing one or look at this example of pie chart, right? So that's a very important one. You can see, and anyone can construct a pie chart. Most of all using technology like Excel, StatCrunch, and we have so many other different technology that you can eventually use. You can use StatDisk, you can use Minitab, StatCrunch, TI. 84 or 83 plus calculator also can construct pie charts, and you can use Excel. That's the most important one. And there is one that we call R that can also help you to do it. But in our examples here, we would either use Excel or StatCrunch to construct, these graphs. So this is a pie chart. As an example, because my goal is to cover as many examples as possible with you, these examples right there, it says uh, recent annual growth. You know what? I'm going to copy. No, let's copy, paste. What I'm going to do, I'm going to remove B. All right, so we can do A. So for these examples, what we learn here, it says that construct a Pareto chart. So we're going to construct a Pareto chart. Remember, we use Pareto chart to construct a Pareto graph to display qualitative data or categorical data. So the access to do both construct a pie chart and a bar chart for this. So let's construct a Pareto chart first. So we know Pareto chart. Oops, sorry. I'm gonna put very straight line. No, we're too far. Let's do it here. Remember, our goal here is to construct a Pareto chart. Now, identify our category. So it says we set annual growth revenue millions of dollars for leading movie studios are as follow 20. You know what? So we're gonna call the first one the 20 um all right. So we're gonna go with 20th century fourth century. All right. Buena Vista, Paramount, Sony Columbia, Universal, and Warner Brothers. Are they likely to be reasonable accurate? So what we're gonna do here, I'm gonna just put a letter for them. So what if I put this one on the century? Would that be fine? And I would say BV for this one to make it much easier to use. Okay, Paramount, I think I can put SC right? For this one, Universal, Warner Bros., WP. So let's put them here, but the most important, identify the one with the larger, because our goal is to identify the one with the larger, um, uh, frequency. Which one has the bigger number? Yes, that's Buena Vista 3092. So what we're gonna do, we're gonna put Buena Vista as the first one. Buena Vista. Okay, I put BV for Buena Vista. The second one with a larger number, what it is? Yes, is the Warner Brothers. So you see Warner Brothers 1941. So we're gonna put Warner Brothers because we put them like this, Warner Brothers. The third one, we would see you can pay attention and check. It's 1070 is 1772, so it's universal. Universal. The fourth one, you can see um, it is 1300 of us. So that's Sony Columbia. So let's put Sony Columbia. Now, will you have more? Yes, we have Century Fox. Century Fox. And the last one is Paramount. Okay. Now, in terms of numbers, as we said, we know we can go up to 3090. So if I put uh, 500, 1000, 1500, 2000, 2500, 3000, 350. So we said this one is 1000, no 500, sorry. I'm trying to put those numbers. So that's 500, that's 1000, 1500, 2000, 2500, 3000, 3500. So that's at some point what we have on the vertical axis. Remember the frequencies because those are the frequencies. All right. Those are the frequencies. And down on the x-axis is the categorical. So how the graph would be, we know that Buena Vista goes to 3090, so we can go up 3000, maybe somewhere here, and okay, sorry for this, but this is the bar I might have. And the second one, Warner Brothers goes 1900, so less than 2000, so 1900, somewhere here, 41. So there is no arrows, okay? So Excel playing with me. I mean, no, not Excel. My pencil is playing with me. So then universal is 1070 again between up there. So we're gonna have 1017 something, maybe somewhere here. Remember, it's going in ascending order. We're gonna go Sony Columbia 1300. That's below. I'm sketching it, okay? So I'm sketching it. Doesn't mean it should be exactly like this, but you see there are gaps between the bars. So that's why it's not a histogram. So remember, if it was a histogram, the bars were going to attach to one another, and you cannot use histogram to display qualitative data. Use histogram only for quantitative data, numerical response. All right, so let's go for Century Fox. 1000 something, maybe over here. And then we have Paramuth 700. So 700, maybe somewhere here. All right. So this is a Pareto chart. Pareto charts, you have to display your data in a ascending order. That's very, very important. A Pareto chart is a bar graph for categorical data with the added stipulation that the bars are arranged in descending order according to frequencies, right? So the bars decrease in height from left to right, as you can see. So if we try to do, I usually do one of them and I let you to enjoy the second one on your own. But if you really want me to try well, for you the next one, I'm going to copy again and put it down here very quick. And in this case, we would remove the first one. Okay. And all right. So oh, for the categorical, for this data also, we were asked to construct a pie chart. So what I'm going to do, I would prefer to click on Insert. Let's click on Insert, and I'm going to take a circle. So circle, where are circles? This is circles is right there. So I would consider this one, then I would make it remove the field. Oh, no, I know the line must be black like some point. Okay, I'm going to construct a pie chart. As we said, for pie chart, remember, for pie chart, remember the circle is 360. So what I'm gonna do first of all is to find the relative frequency. Okay, relative frequency is very important. So how I'm gonna do it, because I know the frequency. So if I construct a little table right there, I'm gonna construct a little table with because we send annual revenue for the movie studios. So movie studio, right? So remember we said we have BV, and that the frequency is what again? What is the frequency? The frequency is 3092. We have WB with Warner Brothers. It is 1941. We have the Universal. Universal is 1772. You have also Sony Columbia, SF for Sony Columbia. It's 1304. What next? We have Century Fox, CF for Century Fox. It's 1082. And we also have the Paramount. It is 757. So remember, those are the frequencies, but my goal is to find a relative frequency. If you do it manually, how you intend to do it, first of all, you need to make sure you add up everything. So that's the first step to go. You need to add all of them. Okay. So when you add, Let me grab a calculator because I didn't do it before that. 3092 plus 1941 plus 1772 plus 1304, right? Plus 1082 plus 757. So totals in this case is 9,948. And you know how to find the relative frequency. If you forget how to find relative frequencies, I would certainly advise you to go back and watch the previous videos. But in terms of relative frequencies, remember, our goal is to divide. We need to divide each data by the totals, like 3,900 2092 divided by 9,948. So what we do, divide each of them, 3,942 divided by 9,948, okay, 0.31. So we can say that's 0.31, okay? Now, if we go with the next one, 1941 divided by 9,948, we're gonna have 0.9195. Let's go with the third one, 1772 divided by 948, 0.178. Let's go with 1304 divided by 9948, 0.131. Let's go with the next one, 1082 divided by 948. We're gonna go with 0.109, okay? So we said 757 divided by 9948, we have 0.076. Remember, the goal here is to make sure that you know, is to make sure that we find one at the end, 1%, 100%. All right. So maybe it's gonna be a little bit off because of the decimal, but how to find each portions in degrees? To find each portions in degrees, what you need to do, take the relative frequency. Remember, you take the relative frequency, you multiply it by 360. For example, for the first one, what we're gonna do 0.31 times 360. That's what give us in degrees. So remember, when we do the first one, okay, we have 5.31. We multiply it by 360. It gives us 100. 11.89 degrees. And I'm gonna do the same for the other one, 0.195 times 360. It's give us 70.2 degrees. Okay, 0.178 divided by times, sorry, 0.178 times 360, 61.84 degrees, 0.131. Oops. No, 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 no. It did something wrong to me. Okay, hold on. 0.131 times 360, 47.16 degrees. Now, 0.109 times 360, 39.24 degrees. Now the last one, 0.076 times 360, 27.36 degrees. So the total must give you 360. If it's not giving it to you, probably for some decimal, that means we're supposed to take either 2 digits for the relative frequency or 3 digits, etc. Now, how to display this? You can choose to display it any way you want. Let's say in this one, we know half of this is, if you do half, it is um, it is 180. If you take a quarter of this, each quarter is 90 degrees. If I need to go with 111, almost 112, I would imagine it would be something to the middles, and then maybe like this, right? So for me, I would consider this to be, oops. I would consider this to be fine, okay? So for me, this part right here would be Buena Vista. Um, for Warner Brothers, 70 point something, because I sketch it, maybe 70 point something would be like this from the middle. So that's Warner Brothers. That's Warner Brothers portions. Then the next one would be Universal 61. I try to do it as I can. So I would say this is Universal part. And you have 47. You help me please if I do not do it correctly. That's one is um Century. No, no, Sony Columbia. So that's Sony Columbia, right? Now let's put 47, maybe 40, no, no, 39. 39 would be, I'm sketching it, right? That would be 39. So that would be Century Fox. Now then, oh no, I'm almost done. I'm already done. So that means those are not enough then. I believe we're gonna continue to do Universal 61. Um, Maybe 61 is bigger than that, because what you can do is use a protractor. Of course, when we do it in Excel, you would see it would be different. So that would be at some point the Universal, that's Sony Columbia. Then after Sony, you have the Century Fox, that is 29. The 39, so we're gonna have Century here and Paramount. Okay, so that's at some point how we would intend to graph, manually, but feel free to do it using technology because it's much beautiful and you have more options. It's much faster. That's why I do only one. Okay. Uh, yeah, so uh, uh, that's what I do only one. Okay. So that's very important to do. So I do one and I would let you to enjoy this one. Let's move on with the frequency polygons. If you can graph the All you have to do is to graph a histogram, and then the polygon would pop up. So polygons is a different graphs to you can use to display quantitative data. So I said that we were done with quantitative data. We're not, because a frequency polygon, use line segment to point location directly above class midpoints. A frequency polygon is very similar to a histogram, but a frequency polygon use line segment instead of bars. So if you know the midpoint, remember midpoint, you add up the class limits for each class and divide by 2. That's how you find it. A frequency polygons, as we said. So in terms of for variation, a variation of the basic frequency polygon is the relative frequency polygon, which uses relative frequencies, like instead of using the frequency in itself, for the vertical scale. An advantage of a relative frequency polygon is that two or more of them can be combined on a single graph. Okay, so very clear on how to do it. This is an example of a frequency polygons, right? You only need to identify the midpoint. Once you find the midpoint, then you can graph it, you connect all of them together, right? Very important. Now, let's see another one where you can combine more than one polygons in the same graph. So relative frequency polygon for daily commute time in LA and Boise. So that's an examples of what we did before. All right. Now, what we can do, I'm gonna do only one of these two examples and you feel free. Oh, the good news, I can see for these particular examples, we already construct a the frequency distribution table that I would probably go back very quick in section 2.1 where we construct it already. What I would ask you to do is go back and watch the previous videos where we have this type of so that's this one, but those are the frequencies. But what I'm gonna do, let's see if we did better than that with that table, right? Okay, I think that's the one. We didn't do everything, but I can just add, what can I add? Did I add to these? I didn't add the class boundaries and everything. You know what? What I'm going to do, I'm going to copy the table I started here because if you don't know how to proceed, please go back and watch these videos. It's gonna save us a lot of time when we graph it. Okay, now let's put it here. Oh no. Okay. All right. So this data set, it's about daily commute time in Chicago. So we have about 50 data here. The questions, remember how to construct this data, these frequency distributions. We need to use the lower class limit 0 with a class with 5. That's why you see on the lower class limit, the difference are all 5 0. Sorry. So the class width must be 15. You see, it's 0 plus 15, 15 plus 15, 30 plus 15, 45 plus 15, 60 plus 15, 75. So that's why you see on every class interval, the difference is 15, right? And the upper class limit and lower class limit. So what we did, in order to find the frequencies, you must count all the data from 0 to 14 and put it on the first row where we see 0 to 14. And in this case, it is 5. And you continue the same way. What we didn't do in these tables is also to find the midpoint. So you can also include the midpoint. That's what you need to construct a polygon. Now, to construct a midpoint, you need to add the class limits and you divide by 2. For example, 0 plus 14 divided by 2, that make it 7, right? So that's we're gonna have the first one as 7. Okay, that would be 7. So I put 7 here. 15 plus 29 divided by 2, that's the next one. We must do 15 plus 29 divided by 2. That's the next one. 15 plus 29 divided by 2, that's 22. We do 30 plus 44 divided by 2. You do 30 plus 44. Oops, no. Okay, I think I messed up again on this. So 30 plus 44 divided by 2, that 37. All right, and we said 60 plus 74 divided by 2, that would make it 52, right? And next would be 67, and next would be 82, right? So those are the midpoints, but we can also use, because what they said, use the frequency distribution to construct a polygon. So we can do it with the frequencies. All right, this is what we're gonna do. Our goal is to construct a polygon. On the horizontal axis, don't forget you're going to have the class intervals. But instead of having, for us, it's fine now to do the class boundaries or the class intervals. Remember, in the previous video, I mean, the first video, I showed you how to find all of this. So what you need to do is make sure that you put the midpoints. Down here, you're going to have the midpoint. So for example, you have 7, 22. That's what fall exactly in the middle. 37, 52, 67, 82. So we can make sure we have something like that. Of course, what's come before. As you can see, what's the difference between each midpoint? Is 15. So for us, we can put a -8 somewhere here. Even though you don't see it, we're gonna put a -8. That's where we're gonna continue. And plus 15 here would be 97. So you start with on the axis and you're gonna finish on the axis. Right. Next is to the frequencies. Remember the frequencies go up to 16. So if we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So remember, this is 16 here. This is 1 here. 2, 3, 4, 5 here. 6, 7, 8, 9 here. 10, 11, 12, 13, 14 here. What else? Do we have another one? Yeah, I think we have 5 twice. Okay. Now let's graph it. As I said, we can start on the axis at the lowest point. The next point is 7 is correspond to 5. 22, 16. So for us, we need to connect the dots. 22, 16 is here. You have another dot. So we're gonna go up here to that dot. And now 37 is 14. Now, 52 is 9. Okay. 50, 67 is what again? Is 5. And we have 82 is 1. Now you go down here. So this is at some point our our polygons. The polygons, first of all, the most important is the midpoint. The midpoint, you add up the lower and upper class limit of each class divided by 2. All right, so that's all exactly in the middle. So that's how you need to proceed to construct a polygon. I leave the last of the other exercise for you. I hope you enjoy it. But one conclusion thoughts, in addition to the graph we have discussed in this section, there are many other useful graphs, some of which have not yet been created. So the world needs more people who can create original graphs that enlightening us about the nature of data. So of course, we expect you can see that in the visual displays of quantitative information, Edward Toffel offers this principle. For smaller data sets of 20 values or fewer, use a table instead of a graph, right? So using a table is better. A graph of data should make us focus on the true nature of the data, not on other elements such as eye-catching or distracting design features. Do not distort data. Construct a graph to reveal the true nature of the data. Almost all of the ink in a graph should be used for the data, not for other design elements. So hopefully you can follow these thoughts and also be ready for the next section, because the next section in this chapter would be about how to construct scatter plot, correlation, and regression. Take care. I'll see you in a different video.